Struggling with complex exam concepts? Let us help you build your brain power. Master your studies with ease. Visit examconceptbuilder.com today.
And inequality, like less than, greater than, or equal to, define exactly how these numbers relate to one another. When we start combining those numbers with decimals, structure becomes everything. Let's look at 7.6 plus 19.0. For addition and subtraction, aligning the decimal point is an absolute requirement. You stack them vertically, matching the points exactly, and then calculate straight down to get 26.6. Multiplication uses a different mechanism. If we have 7.2 times 0.21, we temporarily ignore the decimals. We multiply them as whole numbers, 72 times 21, which gives us 1,512. Then we count the decimal places we ignored. 1 place in the first number, 2 in the second. That's 3 total. We shift the point 3 spaces left in our result, landing right at 1.512. Division has its own structural rule. Take 3.6 divided by 0.004. Working with a decimal divisor is unnecessarily messy. We fix this by multiplying both numbers by 10, 100, or 1,000 until that divisor becomes a whole number. Here, shifting the decimal 3 places to the right on both sides turns our problem into 3,600 divided by 4. A complex calculation becomes a clean 900. Decimal calculations operate using the exact same logic as whole numbers. The only difference is that you must respect the strict positional rules of the decimal point before you start solving. This brings us to fractions, starting with 3/4 plus 4/5. Before we do any math, there is one unbreakable rule. Never add the denominators together. You cannot combine pieces of different sizes. This step right here shows the mandatory workaround, finding the lowest common multiple. We list the multiples of our denominators, 4 and 5, until we find the smallest number they share. Here, that shared foundation is 20. Now we apply the rule of equivalence. To turn our denominators into 20, we multiply the top and bottom of each fraction by the exact same number. 3/4 becomes 15/20, and 4/5 becomes 16/20. The ratios haven't changed, but now the pieces are the same size. With matching denominators, we simply add the new numerators across to get 31 over 20. Since the top number is larger, we divide 31 by 20 to convert this improper fraction back into a mixed number. We get 1 whole with 11/20 remaining. Multiplication bypasses this process entirely. If we take 3/8 times 1/5, there is no need for common denominators. We multiply straight across. 3 times 1 gives us our numerator of 3, and 8 times 5 gives us our denominator of 40. The result is 3/40. The operations require different rules because they represent different mechanical actions. Adding fractions means you are trying to combine physical pieces, which requires building a shared structural foundation through an LCM. Multiplication scales the existing pieces directly. Division uses a specific sequence called the keep, change, flip method. For 3/8 divided by 1/5, we keep the first fraction exactly as it is. We change the division sign to multiplication. Finally, we flip the second fraction to find its reciprocal, turning 1/5 into 5 over 1. Look at this problem, 1 3/4 divided by 2/3. Pause the video for a moment and consider the format of that first number. Try to determine how it must change before you can apply the division rules we just covered. That mixed number cannot be processed in its current state. We convert it by multiplying the whole number by the denominator and adding the numerator. 1 times 4 is 4, plus 3 is 7. Our mixed number is now the improper fraction 7/4. With the equation formatted as 7/4 divided by 2/3, we can run our sequence. Keep 7/4, change division to multiplication, and flip 2/3 to its reciprocal, 3/2. We multiply straight across. 7 times 3 is 21, and 4 times 2 is 8. That gives us 21 over 8. Finally, we convert that back into a mixed number by dividing 21 by 8, leaving us with our final answer, 2 5/8. Advanced mechanics, like the division flip, require a simplified starting point. You must strip mixed numbers down to improper fractions before you can execute the calculation. Let's put the entire rule set to the test with one final problem. 3/4 minus 2/3 inside brackets, divided by 3/4. Strict order of operations dictates we solve the subtraction bracket first. That requires an LCM. The lowest common multiple of 4 and 3 is 12, which transforms our fractions to 9/12 minus 8/12. That collapses to 1/12. We take that resulting 1/12 and move to the second half of the problem, dividing by 3/4. We apply keep, change, flip. Keep the 1/12, change to multiplication, and flip 3/4 to 4/3. Multiplying straight across gives us 4/36. Calculating is only half the job. Simplifying to lowest terms is mandatory. Both 4 and 36 are divisible by 4, so we divide the top and bottom to reduce this down to a final answer of 1/9. Take a screenshot of this summary poster for your notes. Mathematical proficiency comes from identifying number formats and applying the specific logic sequences that govern them.